All right, cool. Let's do this again. Welcome to SciJug. Some people call it CJug. Either are cool. We are a volunteer-led user group for app devs in the Central Iowa area. Obviously, virtual, we can expand to other places. So thanks for joining if you're not from the Iowa area. What we're here to do is just provide a place for learning and networking with an emphasis on Java and JVM ecosystem. Not necessarily exclusive to that. So here's, if you're one of these, this is probably a good place for you to come hang out. App devs, software engineers, architects, junior, senior, devs, students, or front-end devs, anyone interested in learning. So we try and encapsulate a variety of different topics at different levels to, keep things interesting for those and try and keep our scope broad enough to capture whatever people want. We have monthly meetups. So every single month, our plan right now is virtual for the most part. We plan to have an in-person one every 3 months or every quarter. Our first in-person one will be the next one, actually. So stay tuned for details on that. And our objectives are to learn, teach, share, and network. So you may be thinking to yourself, can I speak at SciJug? Am I cool enough? AKA, am I super smart? Yes, absolutely. You don't even have to be super smart, but I bet you all are. It doesn't have to be a big talk. It can be 15, 30 minutes, 60-minute talk. Can be a lightning talk. Topics can be just about anything. Obviously, we like Java things. It's a little easier to fit in, but it can be, doesn't have to be programming related. Could be, agile methodologies or anything outside of that might be helpful for people or interesting for people just to talk about and share your thoughts. And if you'd like to speak at a SciJug, get a hold of us on LinkedIn and Twitter or X or whatever they're going to call it next. And give us, we'll work you in. And again, anyone can join in and contribute. So, and we appreciate it. Like Ryan over there. And hang around for the end. We have 2 JetBrains codes to give away at the end for a raffle, which we'll do towards the end. With that, I'll let Ryan take it away. He said this is his self-proclaimed 18th time at SciJug or something like that. We have no way to fact check him, so we'll let him take it away.
Right. Yeah, I don't think it's quite 18, but it might be close. I think the first time I probably talked at SciJug was like, I don't know, it was in the aughts at some point. I think I might have talked about cold fusion. So that's that's dating me quite a bit from back when cold fusion switched from a C++ backed process to Java, and you could start like getting Java objects and stuff like that and writing your cold fusion in Java. And of course, that was like Java 4 or something. And now we're on like 23. It's a brave new world. Let me figure out how to actually present this. Where's the presentation button?
Good question. I always thought it was at the top.
I would think it was.
If you like expand there's like a down arrow in the top right. Is there like a way
that's like creating a new slide?
Oh,
maybe I need to select this. Oh, it's got to be around here somewhere. Oh wait, what's this little thing down here? Who knows how to use Google presentations now? How did they do this?
I'm
dumbfounded.
Google.
Normally it's in the upper right corner.
Yeah, that's what I was gonna say.
Yeah, that's
you're not seeing the full toolbar for some reason. Either it's
Or
collapsed or what does
Maybe.
the menus?
what is
is-
that?
Let me
Yeah,
try
like
to.
that.
Let me.
Yeah, there you
let me-
go.
Have you tried turning it off and turning it
That's
off?
exactly right.
All right, I'm just gonna do it this way, I guess.
What's the drop down on the top right there? It might have
Yeah,
more.
that little
Oh
arrow.
wait,
What's that?
it's hidden by all of your faces.
Oh, there
many
we go.
engineers?
There we go. There we go.
We did it.
Slideshow.
Wait,
Hit that
there we go.
next. Yeah,
All
there you
right,
go. There you go.
We did
We did
it.
it. We did
First
it.
try.
33 of us.
Both win.
All right, so I'll introduce myself. My name is Ryan Bergman. I'm originally from Des Moines, Iowa, so I grew up in Beaverdale. And I'm principal engineer at John Deere Intelligent Solutions Group. My interests are computers, large scale system design, fine art, linguistics, sociology, and how technologies impact society. I have been a software engineer in the Des Moines area for 24 years now, and I have presented at CI Jug many times, as well as doing talks and at various conferences. So you may have seen me at various things. I first got my start with test-driven development, which is the topic we're going to be talking about started looking into it in the early 2000s. I was working a lot at that time in Cold Fusion, PHP, and Perl. Those were pretty much the only languages I was using on a regular basis. And TDD was not something that was really done in those languages. They didn't even have frameworks for them. TDD was almost exclusively at the time a Java thing. And it seemed like it needed a lot of stuff for it to happen. You needed fancy IDEs. You know, I coded all my Cold Fusion in like BB Edit and or other very simple editors. And so I kind of knew the idea of what it was, and I had started to write kind of diagnostic pages into the Cold Fusion apps that I was writing that would execute the system and then report to me what the results were. Now, I would not call what I was doing TDD. I would not even call what I was doing unit testing, but I was doing testing. I was doing kind of automated testing where the system was testing itself. At this time, I was working for a little company called GeoLearning. We went through a process of rewrote our entire stack out of Cold Fusion and into C#, and had a lot of issues with that system. And so kind of had a critical point in the company where we really needed to get the system working and have high quality, or the company was going to die. We were all going to be out of jobs. And so we wound up hiring a bunch of coaches and kind of going through, an agile transformation. We had been doing Scrum and stuff like that pretty early in the existence of all of these things. But TDD was kind of a new thing. And it really changed the way I looked at software development, and it changed the way the entire company looked at software development. And it was really a game changer for me. I was really at the point where I was kind of thinking that, if this is what software development is, and maybe I don't want to do software development, and having these tools at my disposal and getting coached from what was in hindsight some really, really great coaches, people who have been very involved in the Agile and XP communities, and who themselves were trained by the people who came up with all of these things. And so I was really blessed to be part of that kind of community and getting that kind of mentoring in my career. And I'd like to pass that on as well as I can. So we're going to talk about TDD, and which is test-driven development, and how you're not. Which way does this thing go? There we go. So let's, and how it's impacting you and how you see it, and how you may have experienced it in the last 20, 30 years since its conception, almost 30 years. So what is test-driven development? A little bit of a history on it. You can trace the ideas of test-driven development all the way back to mainframe days, where people would take, these are punch tapes, and this is the first recorded version of something like TDD happening in computers. So back in the 60s, and we had mainframe computers, and you may be familiar with punch cards. There was also punch tapes, and punch tapes would kind of goes both ways. You can, type into a terminal what your program was, and it would wind up spitting out a tape that basically produced the binary data. So you can think of these tapes as essentially compiled binary data. And so what someone figured out to do was that they would take the tape and they would punch it by hand and say, this is what the program should look like if I punch all these holes by hand with like a pen or something like that. And then they would write the program, and then they would execute the program, and it would spit out the tape. And then they would line that tape up with the other tape and see that the holes go through. So you could hold them up to the light, and everything should have a hole going all the way through it. And that was really the first version of TDD. Later, in the 90s, this guy, Kent Beck, is credited with, and he's the one who says that he rediscovered TDD rather than inventing TDD. But many people consider him as the father of TDD, and is credited with the first frameworks for performing it in modern languages. And I believe the first language that he produced a TDD framework was Smalltalk, and then he was responsible for XUnit, which was like the first one in Java. And Java really had the first widespread TDD framework, unit testing framework in existence, other than Smalltalk. But Smalltalk's a proprietary language, even though it's really cool. We did that one too. Some other important influencers included people like Ward Cunningham and Ron Jeffries, and some of the other signers of the original Agile Manifesto. I think Ward in particular made a lot of important contributions to it. And this went hand in hand with some of the ideas that came out of what we call extreme programming. So, and extreme programming includes TDD, but it also includes a lot of the other stuff that became Agile. I don't really like using the word Agile anymore. I think it's fairly corrupted and is pretty meaningless, and now it's associated with things like safe, which is unfortunate. So I've kind of gone back, and now I just say I'm an XP programmer. I don't say anything about Agile, but we'll talk about Agile and how it intersects with all of this. So what's the basic idea of TDD is that we are going to create a failing test. We are going to make the test pass. Then we are going to refactor the production code until it's at a point that we are happy with it. And then we move on, and then we'll create another failing test. And we do this at a fairly microscopic level within the code. So here's a very simple example. I'm going to make a class, and it's going to have a method that is going to take a bunch of words, a bunch of strings that I'm going to pass to it in an array, and it's going to join them together with spaces in between them to form a sentence or something. So my test starts and say, can we join with spaces? We have our class that we've created, and then we're going to say, if I take hello and world as two parameters, it will concatenate them together as hello space world. and I can write this test fairly easily. And then I can write the production class after I've written the test, and it joins them together. Now, this is kind of a stupid thing to do because Java has string join now. So it's like, well, why even wrap that up in a class? But this was designed to be a stupid example. So it's a very simple thing. So recommendations for TDD, and I'm not saying requirements, but these are recommendations for how TDD is, how these tests really should look. And I want to emphasize that unit testing and TDD are not necessarily the same thing. The order in which you do things is important, and the philosophical mindset of how you're doing things is very important. But some of the things we like to think about with unit tests are TDD unit tests are, the test should be small, ideally like 1 to 3 lines. The test should be isolated, meaning there shouldn't be a lot of, if I change this code over here, it's going to break 1,000 tests. Now, I'm very lenient on that rule, and we'll talk a little bit about that coming up, but that's my least favorite rule of these rules. I should have put it last. Tests should be easy to read. Tests should fail for one reason. They really should only be asserting one thing. These are all, I'm very pragmatic. I'm not really religious about anything. So, everything has give and take. But these are general good ideas to kind of go by. As you can see, these 2 guinea pigs here, this is Ziggy Stardust and Mr. Biscuits, and they are isolated and small. Tests should also, I should say, be very fast, like extremely fast, because you want to be able to run lots of them. Those 2 guinea pigs are not fast. So some of the other benefits is TDD creates contracts. And this is really the idea that Kent Beck was going for, like when he started it. We want the tests to create a contract which documents the behavior of the code. And this contract intentionally makes the code harder to change. That was Kent's, one of the goals was that he didn't want to be able to make changes to code and not know that he broke something. So the tests put in place this contract over it. And so if the functionality changes, then the test has to change too. The test fails, and now we know, oh, well, maybe this shouldn't have changed. Maybe we need to do something else. Maybe I need to talk to my customer to figure out, if we make this change, then it's going to change this other thing. We need to talk about that and spur conversations about how we want our systems to behave. By the way, this picture is of me in like the 90s on Halloween, where I tried to get people to sell me their soul for a donut. And so that's my contract. So what do we mean by contracts and behavior? And this is going to get down when we're getting into testing. There's a big difference between, there's 2 main schools of philosophy behind TDD, and particularly around how are we going to deal with dependencies? How are we going to deal with interactions between 2 different sets of code? So there's 2 styles. One is called the Detroit style. I fall into the Detroit style. Almost everybody I know that's into TDD is also Detroit. And in Detroit style, we use real objects whenever possible. We will use test doubles or mocks when a collaborating class is awkward, meaning it's going to hit IO, it's going to be too complicated, it produces results we would rather sidestep, or some other reason. But it has to be a good reason. It can't just be like, I'm just going to mock everything. We don't like, in the Detroit style, we don't like marking everything. We like to try to use real objects as much as humanly possible. There's another style called the London style. I have never actually met anyone who adheres to the London style, but I see an awful lot of code and tests that basically do the London style. Not well, and I would assume that whoever founded the London style probably they're probably doing something else, but I've never really quite understood what they're going for. But it uses extensive use of mocks for almost all collaborating classes and focuses on the integration of the system. So how classes talk to one another. And this is actually what you see in the real world when you go look at random repositories that are doing TDD. You see a lot of uses of mocks. I don't like mocks. And I really don't like mocking frameworks, even though I really think mocking frameworks are cool from a Java standpoint. So how does TDD benefit our code? Because it's more than just tests. And this is my own kind of take on it, is that TDD drives simplicity through pain. TDD is painful and difficult to accomplish with complex code. Human beings like to avoid pain. And so it drives human beings to create code that is not painful. And simple code has higher quality than complex code. And this is kind of my mantra of what it really means to do this. Unfortunately, human beings will also do things that are extremely painful if they don't know how to do it otherwise, which is, I think, the problem that we've had in the world of TDDs since we kind of came up with this stuff. When I say complex, I want to make sure that we differentiate complex from complicated, because these are two totally different things. Complex problems have many components. So you can think of the life cycle of nitrogen in soil is a complex problem. It involves the air, it involves plants, it involves chipmunks, it involves mushrooms and nematodes and all sorts of things. And any one of those things going wrong can throw off this nitrogen cycle in the soil. You know, a nuclear reactor is not a complex problem. Nuclear reactors are actually fairly simple things. They are a complicated problem. They are difficult. We are, in fact, harnessing a small, simmering, never-ending nuclear reaction, and that is a hard problem to deal with, but it's not complex. It doesn't have a lot of moving parts. Nuclear reactors are actually fairly simple things. We just happen to have a bunch of rods of uranium that are almost going to explode sitting in water. And that's really the whole thing. And we just have to stop them from melting down. So it's not a complex problem, but it is hard. TDD does really, really well with complicated problems. It's much harder to do with complex problems. So TDD drives the idea that we want high cohesion and low coupling in our code. High cohesion means that the code that changes together lives together. That it and low coupling means that the various different modules are independent as much as possible. So we want to group our code very tightly together into the modules that's going to do the various work that's where they're interacting with each other. And then we want things that don't need to interact with each other a lot to interact with each other less, as little as possible. And TDD wants you to do this. It doesn't mandate that you do it, but it wants you to. And it makes it difficult to not organize code this way. That doesn't stop people. They'll still do it. And when we say, high cohesion, low coupling, think of cohesion as like your hand. Your hand is very cohesive, right? You have all your fingers are attached to your hand. My ring finger is not attached to my foot. I do not need to lift my foot up and put it next to my hand in order to use my ring finger. It's already here. It's on my hand. And so a hand is a very cohesive thing. And I can also chop off my hand and the whole thing is gone. which is fine, if you're a Jedi, I guess. Trees this is all very natural. Like things want to have high cohesion and low coupling. My hand isn't also attached to my gallbladder, right? It's only attached to my arm. And that's the end, right? And my hand can do all sorts of cool things. It can write, it can draw, it can paint, and it has a whole lot of functionality, but it doesn't have a lot of dependencies. It's only dependent on my arm. And that's it. It's not, sure, there's an entire life cycle here, an entire body, and it does need my heart, but that's kind of like all the way over here. And that's what we're aiming for. We want the code that does the most work to not have a lot of dependencies. And we want it to be kind of independent of itself. And we want to be able to use it, because code that has few dependencies is easier to reuse. It's easier to test. It's easier to use just in any kind of general sense. And it makes it so that if we do have failures, that we're not looking at a complex problem. We're not asking, well, is it his gallbladder? Why can't he draw? Is it because his foot has a fungus? No, it's probably because the hand has something wrong with it, right? And that's what we're going for. So if we look at this from a code perspective, not talking about hands, this is kind of an example architecture that we typically see. We have, a web application that has some kind of controller. The controller layer is what determines the desired action. And you can think of the controller layer as like the main. If you're doing like a command line application, a web application is really just a thing that has like X number of mains, in my opinion. Every endpoint is a different main. And so that's taking the input, the IO input from the whoever's invoking the program, mapping it into something else, mapping our inputs, and then passing it into like the core business logic of the system. Once it's in that business logic module, which has few public interfaces, then you can go hog wild once you're in the module. And don't be afraid to have lots of classes. And TDD is going to want you to have lots of classes, and it's going to want you to break up things into very small things. But those things don't have to be public. They can be package local. They can be private. You can still test them, and nobody needs to know about them. And it creates this kind of shell, and where we have IO on the outside and business logic on the inside. So things go in, processes happen, things go out. And maybe they go right back out to the user, maybe they go out to a database, maybe they go out to some other microservice or something like that. But we're trying to control for the boundaries of the application. And that's where we want to do test doubles and mocks and everything is in those boundaries. And the inside is basically it's like a Cadbury cream egg. Since we got Easter coming up and it's Cadbury season, I really can't stand Cadbury cream eggs, but it was the best thing I could come up with that people would understand. A Cadbury cream egg has a hard shell on the outside, and that's our IO layer. And on the inside, it's just a big gooey mess. And we can do whatever we want within that gooey mess. There is no structure to it, really. And we're free to do whatever we want and to refactor and move things around and move classes and move methods. And nobody cares because it's just on the inside and nobody can see that stuff. And as long as the business logic is the same, we're free to do so many things with it, as long as we control for the outside. The London school tries to control for like all the sides all the time. That's why I don't really like it. So in our example here, we might create mocks or do one thing for the IO layer where we're pushing data in. We might have a test double or a mock or something like that on the other side for like databases and stuff, or external web services more likely. And but then the inside, which is where the actual business logic is that does the actual business stuff, that we can do whatever we want with. Another benefit is that TDD encourages flow or being in the zone. Because it creates a very tight, very small, very rapid cycle of, I'm going to write a test. Now I'm going to make the production code work. Now I'm going to write a test. Now I'm going to make the production code work. Now, if you're a person like me, my brain has a deficiency in producing dopamine. And so I have difficulty regulating my attention. And having a constant feedback of, there's a little green light, or there's a little red light, now there's a little green light, and there's a little red light, and now there's a green one. That's great feedback for me, and it helps my brain produce dopamine, which wants to keep doing that. It's the same thing that keeps you from, that like makes you do things like, I have to go find all the Korok seeds in Zelda, right? Or I have to do whatever I want, as long as you get that feedback so that you're getting back, I know that I'm making progress. I'm not just kind of slogging at something and I don't know if it's going to work. I constantly know that this piece works and this piece works and this piece works. And this also falls in with my good friend Jeepaw Hill, and who's a fabulous Agile coach and human being. He has an idea called many more, much smaller steps, and it falls into that. That's like we could do a whole presentation on many more, much smaller steps. In fact, we should probably get Jeepaw talked about that last year, I think, at CI Jug, but we can get him again. Or maybe it was the .NET users group. But it falls into that. This is related. There was a study recently on flow, a big study that just came out. Your brain has basically two different neural networks that are involved in you doing things, like coding. One is called the default mode network, and this is responsible for daydreaming and creativity and such. And the other one is called the executive mode network, which does complex cognitive processes. You need both of these things. My brain doesn't do a really good job of regulating which one it's going to do. And in fact, it mostly spends its time probably in the DMS side. What this study found is there used to be a lot of argument about, like, well, which one of these things is happening during a flow state, where someone who is an expert, whether it's coding or whether it's like a sushi chef or something like that, and you watch a sushi chef just make sushi, and you're like, how does this person know how to do all these things? And they're just like kind of going with the flow, and they're like in the moment, right? So there was a lot of disagreement. This new study, they strapped mental stuff sensors to jazz musicians, and then they measured the brain activity to see, because we know what the patterns of these two neural networks look like in your brain when it's active. And for jazz musicians who were not very experienced, both of these areas of the brain were kind of simultaneously going. So there was a lot of back and forth between those two things. But for experienced jazz musicians, or someone like Prince, for example, who you don't think of as a jazz musician, but let's face it, if Prince wanted to be the greatest jazz musician on the face of the planet, he could have been. He probably already was. But for experienced musicians, neither one of these areas of the brain lit up. Experienced jazz musicians were effectively doing the same thing that athletes do. They were just reacting. They were just doing it, and it was instinctual. They weren't thinking about what they were going to play. They just played it. And without any scientific basis for doing this, I think it's very similar with TDD. Especially once you're a more experienced programmer. But even if you're not, the great thing about TDD is it limits how much you have to shove in your brain. It keeps how much you have to think about very small. And so the smaller the thing is that you have to think about, the easier it is for you to just kind of instinctually do it. You know what needs to be done when it's a small thing. It gets very hard when you are suddenly realize that you've changed 35 classes and you have a new class that's 1,000 lines long, and you haven't committed it yet. That can be usually when I sometimes still get into that situation, and usually what I do is I revert the entire thing and start over and try to get to a smaller change set. But that's what we're aiming for. It also encourages emergent design. I actually don't really like the term emergent design, but it kind of goes hand in hand with this stuff, and I'll talk about why I don't like it in a little bit. But we don't. Whenever you start a project, you have this idea of what you're going to produce at the end. That this is, we thought we were going to go make a nuclear reactor, and it's going to be this straight line to there. And in reality, we wound up all over the place, and we ended up with the toaster. When you don't work in small chunks, when you don't acknowledge that things are going to change and we need to react to that change, then that's when you wind up making the wrong thing, or over-engineering it, or doing all sorts of things. And TDD kind of naturally wants you to do things in small pieces. It naturally wants you to keep things simple. It naturally wants you to not over-engineer things or not introduce business logic that you don't need, because you're only writing a test for exactly what you need right now, and you're not gold plating and doing a bunch of other stuff. So what went wrong? I've been wondering this over the last few years. TDD has been around since the late 90s. And I feel like personally that the number of people in the world doing TDD is like the same number of people as it was in 2004. And even though the number of programmers in the world is like quadrupled since that time, we have not trained people correctly or well in this. And there's a lot of there's a lot of bad examples in nature. Like, you open up, if you go to work, I'm sure almost every project you have has some sort of automated testing, but you open it up and what you wind up with is not necessarily good design. And that's because TDD does not magically create good design. And we're still fighting this 20 years later. So this is an example of just something I kind of whipped up. You will find this class in like every repository you open, right? You got a whole bunch of injected dependencies. You have some method, and this method's like getting a bunch of these beans, it's turning them to JSON, it's doing an HTTP request, it's building the entire HTTP request and everything right here, it's passing it in, it's getting a response, it's turning that from JSON into something else again, and then it's saving those, and it's returning this status code, it catches an exception. And it's not even that big of a method, but look at all the stuff it's doing. It's doing an absolutely like enormous amount of work and that's cool that you could do all this amount of work in very, very few number of lines. But testing this is really difficult, because what you wind up with is what you see in classes is in real code bases is you wind up with something like this, where we have a whole bunch of mocks, and then you wind up with win, and this is just the first test. And what you'll see is you'll have like 20 of these, and they'll have basically the same mocking statements, win, over and over and over and over and over again throughout the test. And now, if I want to change this method, I have to mess around with mocks in 20 different methods. I have had situations where this was so bad and I needed to do pretty radical refactorings of a class that I just threw the test away. It wasn't even worth messing with. Because what does this prove anyway? Like, when you have this many mocks and everything is mocked, what does it prove? It doesn't prove anything. It doesn't prove that the business logic of the method was actually accomplished. It's proving that Makito works is what it proves. And that methods call other methods. And that's about it. We don't know that these objects can serialize into JSON. We don't know that they can serialize back out of JSON. We don't know that this HTTP request is going to work, although that's something we're probably never going to know until we actually run the system. And so it's pretty ugly. So I'm going to talk a little bit about, there's an ideal state of how TDD wants you to do things that would make it not look like this. And I'll talk a little bit about that later, but more likely, when you open up a project tomorrow, you're going to face this. You're going to face some class and it's going to look like this. There's going to be argument captors and everything. And so how do we get out of that? How do we fix that without just kind of throwing it away? There's a lot of great ideas in this book, Working Effectively with Legacy Code. I would consider any test that is like that to be legacy code. Now, here's the other weird thing. I have actually seen, oops, I'm going backwards. I have actually seen people do this kind of test first. Where they were like, well, I did it TDD. I wrote the test first. And it was extremely painful. Think of writing this test first without the implementation having any dependencies at all. And you're like, okay, well, what is send beans going to do? Well, I know I'm going to need JSON. And so I'm going to pull in this parser and I'm going to need this and I'm going to need this. And it's really painful. So figuring out some kind of higher level test to test the entire stack of the system today is a good idea. Michael Feathers talks a lot about what he calls characterization tests. I am a big fan of a thing called behavior-driven development, which we're going to talk a little bit about. And behavior-driven development allows you to create tests that are more high level than what we normally do in TDD, which is very kind of low level. But having this level of tests, a characterization test, an integration test, a behavioral test, however you want to define that, gets you kind of those, lets you create kind of spikes through the system. You don't want to do it for all edge cases, but you want to get the general feel for the application and how it's doing things. And that usually will give you an out to be able to refactor something like this into something a little bit better. Behavior-driven development is using, as Liz Keogh is kind of one of the founders of the ideas of behavior-driven development. And she was really responsible for a talk at Agile 2011, I think, that kind of changed my entire outlook on testing. And it really blew my mind because she did this great presentation on doing behavior-driven development without behavior-driven development frameworks. When the BDD movement kind of happened in the late 2000s, It kind of brought along with it a lot of frameworks like Cucumber, RSpec, SXspec, whatever. JBehave was a popular Java one. I don't really see people doing this anymore. I haven't seen anyone do like a new BDD suite for an application. I don't remember the last time I saw one. It's been a long time since anybody's used Cucumber in anything. I don't really like Cucumber. Fitness is a similar thing, although technically it's called an acceptance test driven development tool. And I think that's, you're just splitting hairs on words, but BDD and ATDD are basically the same thing in my book. Fitness is based on Fit by Ward Cunningham, and it extends the ideas of TDD to talk about the system of the whole as a whole and how the system is behaving. And generally, the rules are that it doesn't use a lot of mocks. It may use some test doubles for external side effects. Like we don't actually want to send an email every time we run our tests, or we don't want to make third-party API calls. We mostly want things that are local. And that can include a database, especially now in the world of Docker, where it's really, really easy to just spin up a Postgres database or whatever kind of database, and they're really, really fast locally. Our computers have gotten really, really fast. Behavior-driven development tests are much, much faster than they used to be. And you can run thousands of tests like very quickly. I write all my BDD tests in JUnit. I just build kind of bespoke given when then syntax so that my syntax is separated from the actual production code. The idea is that the BDD test should be an alternate UI to the application. So the same, it's not the UI, but it's just under the UI. Everything the UI was going to do, the BDD tests do, right? And we used to joke that you need to be able to, if you want to write a BDD test, it needs to be able to run on an airplane to China. Back when you couldn't get internet on an airplane to China, but now you can. So it doesn't apply as much anymore. But the tests are still, relative to unit tests, are going to be slow, even though they're much, much faster these days. So you don't need to do like every nuanced little thing. The idea is you define the expected behavior with the owners, with the customer, with your testers, with everyone who has a stake in it, and you define what the test is going to be. And it's usually written in some kind of given, when, then, English, or whatever language. You don't have to be in English, but human language, not necessarily code. But I've found I can do it in code with my own kind of fixtures that anybody can read it. Even product owners who don't code can read it and say, given user logs into the system, when the user looks at the title bar, then it says, hello, Ryan, right? And so we can wrap TDD or BDD tests around essentially our TDD. So we define the expected behavior, we create a failing test for that, and then we get into the much tighter, faster cycle of TDD and writing our unit tests and building out all of our code. And eventually we get to a point where that BDD test passes as well. But the BDD test gives you this whole cycle around the whole app. And if stuff is in here is ugly, then when we start off and if we're talking about a legacy system, we can create the same test and it will, pass at first, right? Even with our older, uglier code, it'll pass. It's doing the right thing. And then we can mess around in here all we want. And if this fails, then we know we've broken production code. And honestly, it's, I have had my butt saved by BDD tests more than I've had anything ever save my butt. I highly recommend it. And so here's an example, a little fuzzy, but of a BDD style test that's just in code. This is UniRest. You may be familiar with UniRest. It's an HTTP client. It's owned by Kong, but I am the maintainer of UniRest because I got in an argument with the founder and CTO of Kong on Twitter because they weren't patching it with security stuff. And so I yelled at him angrily on Twitter, and then he said, well, why don't you maintain it then? And I said, fine, I will. And yeah, so now I've been maintaining it. But UniRest has it's got these tests, and what it does is it's just an HTTP client, and so it has this suite of BDD tests that actually stand up an entire Jetty server, and the Jetty server will basically echo back everything. So it's kind of like HTTP bin, but local, because I didn't want to use actual HTTP bin. And there's a bunch of other frameworks that will do the same thing. So you make a request, and it'll just return back, here's the query parameters you sent me, here's the body, here's this, here's that, and that. And it all just comes back as JSON in what I call a request capture class. And then the request capture class has all the assertions built into it. So I'm saying, call this mock server, send these 2 cookies, get back the result, and then assert that the cookies that I set when I sent it to you came back. So this is a lot of really complicated code, and it involves like actual making real HTTP connections and sending things over a real HTTP connections and parsing cookies and everything like that. And so it's a lot of code that's in between there. There's still unit tests. Here's a unit test that just tests that, for example, the same site argument within a cookie string gets parsed into the same site property of the actual cookie object when you get back a cookie. It's a very simple test. It's very isolated. It's very small. It's very fast. But it only tells me this one little tiny thing. It doesn't tell me how the entire thing worked. And now my cat is very weird. So the mocks. Let's talk about mocking as part of this. So mocks are what make a lot of existing classes, a lot of existing TDD difficult. I think it's yes, Sean is correct. All mocks are lies. They are just different forms of lies. And so every time you see this, when you see when repo get all beans, then return these beans, you don't know if it's actually going to return those beans. Like, that's just what you said in this in this test class. You're just making up stuff. You don't know what it's going to do. And so it is a lie, and then you have all of these, and they get very repeated, right? So some of the rules, the rule I tend to like is I want to use real objects if I can. If I can't use real objects, I'm going to use hand-rolled mocks. If I can't use hand-rolled mocks, or doing so is really annoying, then I'll turn to a mocking framework. And I still turn to mocking frameworks. I still almost always wind up with Mockito in my toolkit, because Mockito's really handy, especially when you need to mock something that has 80 methods like HTTP servlet request, right? Or one of those other gigantic framework classes. Because if you want to make a hand-rolled mock of HTTP servlet request, you have to implement, or at least have a signature for, literally 80 methods. And it's painful, but Mockito will do it in like one line. Now, that being said, HTTP servlet request has some very nice hand-rolled mocks in various different frameworks. If you're doing Spring, Spring has a has a mocking module, and then they have mock HTTP servlet request, which is a great class. But you'll run into this regardless. So in this case, I kind of changed this a little bit. Like, what if JSON was just real? What if we didn't mock JSON? I mean, JSON is pretty simple. It's just gonna take a string and it's gonna serialize it into objects, and or it'll take objects and it'll serialize it and turn them into JSON. So why do we need to mock that? Why do we need to say what JSON would do when we very well know what it's gonna do and what it's capable of doing? And why not just let it do what it's gonna do? And so that's what we did here. And that removes several lines from our tests, and it makes it easier to read, and it makes it more real. It makes it, if something is going to get sent to it, if for some reason Cool Bean, which is a record, does something that makes it difficult or makes it impossible to serialize or makes the serialization different, we kind of want to know that, right? And yeah, this class isn't necessarily the place where we would want to know that, but people sometimes in the early days would complain that you shouldn't have something that breaks and it breaks 50 classes. But we have stack traces. You know where it is. You know where the error happened. It's not a mystery. Like, if you have 80 failing tests and they're all the same stack trace, it might as well be one, right? And you can isolate it back down. So using real objects is my preferred method. If I can use a real object, I will use a real object. Hand-rolled mocks are a great alternative to mocking frameworks, and they can be extremely nice when we want, because you can make them do things in much more elegant ways than mocking frameworks can. Mocking frameworks have to adhere to kind of very standardized ways of doing things. They don't know the ins and outs, and a hand-rolled mock can do things much easier. So in this case, I took the repository and I made a hand-rolled mock out of it. I'll show you some of these classes when we get down to it. But rather than the repo being a mock, it's a hand-rolled mock, and it has just a method called a property. And don't worry about like getting super formal with the mocks about like methods versus properties and stuff. You just set stuff. And so we say, well, we're going to set the beans. These are the beans the repo is going to return. Is this list of Fran and Tim. And then the mock client, we can also turn into a hand-rolled. So this is the HTTP client. We're going to set the expected response that it's going to return to some value of JSON. And you can evolve these things. You can get them like nicer and nicer and nicer until these tests are really only like 2 or 3 lines long, even though they're doing very complicated things. But it does mean restructuring your production code. Even when you're doing mocking frameworks, and this is something that I've really kind of only come to appreciate maybe over like the last 4 or 5 years, I kind of finally figured out that, if you have a class and it's getting mocked a lot by Mockito, there's easy ways to wrap up all of those expectations. You can make classes that basically all they are is an enhancement for Mockito or whatever. I keep saying Mockito. There's lots of Java mocking frameworks. There's PowerMock and other ones. Mockito is probably the most famous and most widely used one. But keeping in mind that you don't want to repeat yourself in your testing framework either. There's an example. There's a very large project where I work, and it has a class called security context. And this is a huge project with thousands of classes. And the security context is in like something. It's a very common dependency. It's all over the place. It's the thing that tells you who the user is on the request and what they can do as far as security rules and stuff. And it was Mockitoed everywhere. like literally 1,000 instances of somebody using a mock of security context and then doing the exact same when security context.get user is called, return a user named Phil or whatever it was. And that line, if you wanted to refactor get user, you would literally have to change 1,000 classes. And I wanted to refactor security context. So, and I couldn't really, I didn't also want to make a hand-rolled mock, because then that would mean I would have to go to 1,000 different tests and replace the Mockito mock with a hand-rolled one and do all this stuff. I knew I was going to have to change all of them, but I wanted to change them as little as possible. So I decided I'm just going to keep using Mockito, and I created a class that basically wrapped the security context in the tests, and it wrapped up all of the expectations. So rather than saying when .getUser is called return a user, there's this Mockito expectations class where we say the user is Phil. Just that, just the user on the context is Phil. And then that method delegated to the Mockito, and it did all of the mocking statements that were needed. And sometimes there was a bunch of them in a row. So it's like the user is Phil, but his user type is this, and this other aspect is this. And so you could have like personas in there that would say, okay, now we're using this kind of user, now we're using this kind of user. And then that led to there only being one class where Mockito and the method signatures of the production class are actually mocked. And so if I need to change those methods, I only have one place I have to do it, and it affects 1,000 different test classes. And that's kind of what I've done here, is like wrap up those Mockito. And it doesn't have to be this fancy. It doesn't have, I think most of the time when people do this, you could just make a static class that just has static methods, and then you kind of pass it in. But it makes it much easier and smaller and easier to read, to be able to say, expectations, expect this mock to have a user named Phil, rather than seeing all of the different method signatures and the wins and returns and all of that kind of stuff. So that's a good way around that. Again, don't repeat yourself applies to tests. So this is more of an example of, even if you don't even go to that method, just at least in the test, take your expectations and even your assertions and extract them into methods, in the class. And then I think you'll find that if you do that for one class, you'll be in another class and you're like, hey, I just did this exact same mock over there. And now you could extract these private methods, and you can make them public, and you can make them static, or you can make them part of some kind of interface, and you can pull them out, and then you can reuse them over and over and over again as you need to, and then get the test down to only being 3 lines, given, when, then, and you're done. It shocks me like how much developers will bend over backwards to not repeat themselves and reuse code in production, and not do that at all in tests. And your test classes are the same thing as your production classes. It's all part of the same system. So don't repeat yourself. A really, really cool way to make reusable assertions is by using AssertJ. I am a huge fan of AssertJ and have become so. I've been a convert. GPOC converted me, and it's a fluent assertion library, but it allows you to create your own assertions for different classes. So this would be an assertion class for these cool beans that I've made, and it winds up looking like this. So I'm going to assert that this bean named Elmo has name Elmo, has signature this, and the built-in assertions for assert J are great. So there's things like they have a lot of built-ins for like lists and maps and stuff. So you could, like, if you assert that a map, you could say has this key, has that key, has this value, has a size, and they just kind of stack, and it makes it very, very readable. And that alone is really nice. But the fact that you can do this with like your own classes and you can make very functional assertions that really mean something and are reusable is very powerful. And so I think you could do probably an entire presentation on assert J all by itself. But I'm a huge fan of it. I also had my first pull request approved and merged into the assert J library last month. So I'm now officially a contributor to assert J, even though I've only, what did I add? Oh, there wasn't a way with Guava multi-maps to assert that a key didn't exist. And so I added does not contain key. It had an assert has key, but not an assert does not have key. So TDD, another problem, TDD, is it does not solve the problem of distributed systems. If you have, this was a system architecture in 2000. You had a application. It may have had some kind of layers in it. Maybe it didn't. Maybe it was a cold fusion app. It was just a big bucket of slop. And maybe it had a FoxPro database behind it. And that was it. And TDD worked pretty well here because all of your classes and everything are here in this big bucket of slop in our Cadbury cream egg. This is system architecture in 2024. And we have all these microservices, we have Lambdas, we have different repositories, and every single one of these things could be TDD'd beautifully. Each one could have the most immaculate, beautiful code you've ever seen in your life. And the system still doesn't work because there's no way to test the integration between these various things without doing very slow, big tests and spinning up all of AWS, on your laptop to be able to get this stuff to work. And part of the problem with this is the idea of microservices in general. And this is a great quote from my friend Jessica, who said, microservices, finally, trivial tasks are trivial again, and everything else is impossible. And that is really true. And part of that problem is we go into these things designing them. I've seen so many teams being like, we're going to design a microservice architecture, and we're going to have this microservice and that microservice and this other microservice. And they've decided this before they've actually written the system. And so you don't have the context of like what you actually need. And that's what TDD is trying to give you, is trying to lead you to an architecture that you get what you need out of it. And we don't have that. So, and the fact is, if you can't properly structure a monolith, you're never going to be able to do it as microservices. You have to be able to properly structure code that's all together before you can extract it out and run it in different pieces. Because in reality, there's no difference between these two systems except IO. And that's it. Like, the system on the right is the same as the system on the left. It's just one of them is in a single binary executable, and this one is in 12 different executables. But they're still making the same method calls, and they're still passing the same data to each other, and they're still doing the same processing. But over here, we know what the integration is between these things. And over here, we're guessing what the integration is between these things. And we can do contract testing, sure, but contract testing is also a lie. So we want to do what the tests, you need to listen to what the tests want you to do. It's a very Zen thing to do TDD well. is to listen to the tests. Don't try to force it. Don't try to force your idea of how the system should behave. Let the tests guide you in the direction you want it to go. And don't do anything until you absolutely need to do it at the last responsible moment. And if you do those two things, then what you can wind up with if you start in a monolithic, and I don't really like the word monolith because I'm really talking about a system. And I usually think of monoliths as things that do lots of things that aren't actually even related to each other at all. They just all happen to run in the same thing. But we have a monolithic application. We can test our boundaries. We can test our integrations. We can test all of those things. And then as we learn about the system and as we start to learn about all the other things that go into making systems that don't necessarily have to do with specifically the code, but about how much we have to scale and what our infrastructure is going to look like, and all of those things, those questions can be answered by our code as we develop it. And we will notice that the system needs, these parts belong to each other, following the rules of cohesion. These other parts follow their own rules of cohesion, and they're over here. And now we've kind of identified where our microservices exist. We probably didn't know that before. And then we can finally create those microservices out of our monolith. And again, to do this, and the goal of TDD, even though like the original goal was we want to make a system that breaks and has a contract that tells us and makes it difficult for us to change it. But now we're going to, but if we do it right, our code actually is easy to change. And because if the classes don't have as many dependencies, if they are isolated from each other, if they have good cohesion, they will actually be really easy to change. And the beauty of Java and the other JVM languages and C#, any of the static languages, is that we have the most amazing refactoring tools you have ever seen in IntelliJ. And, I suppose other things do, but, there's some good refactoring tools in Eclipse if anyone still uses Eclipse. But those refactorings, moving classes around, moving methods around is super easy for us. Like, I don't know that Java developers really appreciate well, you probably do, how much harder it is to do big refactorings in dynamic languages. Those tools are not anywhere as good as what you have. It's extremely safe to do refactorings, those big refactorings in Java, and really take a look at the tools you have. Again, I think somebody should do a really nice presentation on refactoring tools in IntelliJ. I think it's always a good subject. So that is presentation. I think I'm kind of running. We only have like 15 minutes left. So I was thinking about jumping over into some other code, but I think we'll kind of wrap it up for now. And if anyone has some questions or comments or wants to chat, then let's chat.
Oh, that was awesome. I was just trying to reading through the chat. I'm sure you didn't get a chance to read it, but there was a lot of people, a lot of good memes first, and then also a lot of people agreeing with a lot of what you're saying. So I think you hit home with a lot of people for sure.
Yeah, Sean, I really hate ham crust.
I know you do.
And I'll tell you why, because I can't ever remember what I'm supposed to do with it. I can't ever,
Yeah.
And they moved everything like 3 or 4 times, and I just gave up. And at least with the cert J, you have autocomplete, right? So you just got to go dot, and then IntelliJ goes, I guess.
The reason I originally liked Hamcrest is because it made sure that my actual value and my expectations were separated from type level checks.
Yeah.
But the fluent interface in a cert J does that also. So yeah, I'm coming around.
Cool. Any other questions?
Maybe one question for me. When you talked about the hand-rolled mocks, can you walk us through like what would be a good fit for a hand-rolled mock, and maybe an example of it?
So I don't really touch on this much, but there's some classes that that unit testing and TDD don't do anything for. They're SQL repositories. You can TDD a SQL repository all you want. It doesn't mean that the SQL will work. The only way you will ever know SQL will work is if you execute it against a SQL database, right? That's not to say that I will never write unit tests or TDD a repository class. I will if it has some logic that I want to test that's interesting. But doing things like, when Spring JDBC template gets this SQL, then return this other thing is a lie. It's all a lie. So things that hit IO is what I will write mocks for. If it's going to hit a database, if it's actually going to make an HTTP request, if it's going to talk to the file system, that's when I write mocks.
Thanks.
Cool.
Yeah.
Anything else? Oh, go
Yeah,
ahead.
I have one thing. This is like, that was awesome, by the way. I have been learning these lessons over the last few years as well, so I'm glad to get a little bit of validation behind some of them. But how has your relationship changed with like the concept of code coverage as you've started doing BDD? Because I've found that it used to be a nuisance and now it is like freeing, and it actually like tells me what things my logic is hitting, and it's very valuable. Have you experienced the same thing?
I haven't paid attention to code coverage in a very long time. Like, I don't even look at it. I think if you're practicing TDD, then your code will have an adequate level of testing. And if you have 100% test coverage, that's probably wrong. You can't ever get to 100%, and the attempt to get to 100% is probably futile, and you're going to make up a whole bunch of lies to yourself to get to 100%. I will look at code coverage if I'm asked to help a new team, get it, and I want to like kind of figure out what the deal is. I might look at code coverage then. And then once you get a team kind of up to speed on what needs to be done, then you can stop worrying about it. It also, for me, has a tendency that if I do run code coverage on my own code and I look at it, I'll get obsessive about making sure all the cases are covered, and I'm not sure that's always needed. So I try not to think about it. Yeah, and my worst experience with code coverage is the idea that you have to have like exactly 80%, and then I go in and I delete 50 classes, and the test coverage goes down. I didn't add any code. I just deleted a bunch of stuff, and they just happen to be really well tested classes, but they're not needed anymore. And now the test coverage goes down to like 79%. And you're like, okay, guess I'll change that to the limit to 79 now.
Yeah.
Cool. Any other final thoughts, questions? All right. I'm going to steal back from you. Thank you, Ryan. That was awesome.
Okay.
If I can find the share button. Let's see here. All right, last final closing things before we do the raffle. Again, we have 2 JetBrains ID licenses for a year. We're gonna give out. Before we get to that, our friends over at DevOps Days looking for speakers. So if you are interested in speaking at that, I think I heard a rumor that Ryan even talked at that one. So if you want to hear more of Ryan and maybe you were inspired to do a talk of your own adjacent to this, feel free to sign up, and I'll post a link in the chat for you to get to that. Otherwise, let's roll for some JetBrains things. So what I'm thinking, so there was a lot of people today, which is awesome. We'll roll and give it like a minute, and if you could just say something in chat, and then Kyle, maybe if you can like contact them and figure out their email or whatever, so we can send them the license.
Do that. Yeah.
Cool, thank you. All right, let's do this.
Big money, big money, big money.
It is playing a ridiculously high pitched sound for just how many people are in here, so that's great. Aditi, sorry if I'm butchering that. Are you around?
Looking. I see no. I think
Okay.
they may have dropped.
Okay.
Roll it again.
Rolling again. All right. The sound is really not pleasant. I know you guys can't hear it, but oh
I
man.
wish I could hear it. Could you mimic it for us?
No, I don't think I can make that sound with my Ishmael.
They are here.
Big winner. All right. Got it.
That's a winner.
All right. We got a winner.
I'll message you inside Zoom to get your email,
All right.
and we'll send you a link.
Thank you. All right. One more. Who is it gonna be? Oh, this is rigged. Matt Vincent. He's our big boss man for a couple of us.
You want it, Matt?
Then again, thanks.
Spin again?
Spin
All right.
I got Ishmael's email.
All right. Awesome.
All right.
Oh. Sean Garvey.
Sean Garvey. I got a David Garvey. Did we put 2 names on the same?
Oh no.
Oh boy.
Oh no, we have a dilemma.
I don't see a Siobhan.
Okay.
I do see a Garvey. David, are you here?
Yeah, I think they dropped
All
both
right.
of them. I think. Yeah. So one
Roll
more
again.
spin.
All right. Bill Davis.
I know Bill.
We're really drawing this out.
Still here.
Didn't
Bill's still he's still in the chat. Are you here, Bill?
Yep, I'm here.
Oh, sweet. I'm gonna direct message you.
Winner, chicken dinner. All right. Awesome. That's all we have. So thank you so much, Ryan, for hopping in here. Thanks for the great memes and discussion and chat. And we'll see you next month. Be on the lookout for Meetup, our LinkedIn for SideJug, Twitter if you do that. We have SideJug there.
We are going to be in person too. So.
Oh yeah, next one's in person.
Yeah, block off your calendars. Travel.
So it'll be pretty sweet.
April 18th.
Yeah. Otherwise, have a good evening and thanks for joining.
Thank you. Thank you, Ryan.
Thank you.
See you guys. We did it. All right, we're gonna send them emails. We can do it.